XNAV. We use GPS every day of our lives. It's one of the most underrated and important inventions in the past 100 years. GPS revolutionized aviation and maritime travel. Farmers use it for planting, harvesting, and weeding. It's used in surveying, electronic funds transfer, credit cards, telephones, and almost all of your smartphone apps. GPS works because we have satellites orbiting the planet. These satellites help determine our global position. But what if we had satellites throughout the universe? In a way, those satellites already exist. Let's pretend we are Galileo and take a look towards the stars. Let's stop thinking globally and take a moment to ponder the universe. There are many strange and fascinating objects in deep space, such as the PULSAR, which is a rapidly rotating neutron star. Pulsars emit regular pulses of radio waves and other electromagnetic radiation at rates of up to 1,000 pulses per second over a lifespan of millions of years. Imagine trying to build a satellite that can do that. The concept of utilizing pulsars for spacecraft navigation has been in development since their discovery in the 1960s. And this concept is called XNAV, X-ray pulsar-based navigation and timing. It's a navigation technique whereby periodic X-ray signals emitted from pulsars are used to determine the location of a vehicle, such as a spacecraft in deep space. Since the 1980s, the Naval Research Laboratory has studied X-ray sources and developed detectors, providing the foundations for X-ray source spacecraft navigation development. Let's put that into as simple terms as possible. Instead of using satellites in the Earth's orbit to determine location, we could use pulses of energy from space to determine our exact location anywhere in the galaxy. Developing XNAV could help us in Earth-Sun Lagrangian point missions, travel to Mars, and even deep space exploration. There is considerable work yet to be done to determine the performance limits for XNAV. But, much like the observable universe, the potential is limitless.